Welcome back. We're going to look at the FastAPI framework by having a hands-on demo. And in this demo, we're going to use the homework pipeline. So I will hopefully be able to show you getting that model that we developed for iris classification available as an API so that you can test it out and use remote RESTful services for doing predictions on new iris samples. As before, we're going to spin up our workbench instance. So I've just logged into my Google Cloud console. Let me close these other branches. Yeah. Once I'm inside, the instance is up and running. Rather, the instance is right now in the stop stage. So I'm going to start it up. Okay, while that comes up, with FastAPI, what we're going to be providing is the ability for an existing model that's already trained and built to be available as an API, which means the existing model is something that's locally downloaded in the same code base as where the API is going to be created. And that code can be like that model can be a job-lib file like we created in the first week's assignment. Or alternatively, you could also take a deploy code lifecycle pattern to its logical conclusion and have even the model generation come out of a entire training exercise. So we'll put all of this together. We'll put the deploy code lifecycle pattern. We'll put the Git flow pattern. All of that together, along with the CD, the continuous delivery practices that we will discuss today, in one final slide that or final workflow that puts all the best practices together. That's when you'll actually fully understand or appreciate the role that each of these tools play. So, but for now, let's go with the approach that the model is available as a job-lib file, and I'm just downloading it from the GCS bucket where I created it at the end of week 1. Okay, so I'll give it a minute more for this to come up. So while this comes up, let me just give you a bit of a background on FastAPI. Before FastAPI came into picture, there used to be something. There used to be other mechanisms for doing API developments on Python, but the key difference is that all those approaches were predominantly powering what's called as a synchronous protocol for serving web service requests. So a synchronous protocol is basically where you fire a request against a particular service endpoint and you wait for the output. And while you wait for the output, you really cannot do anything else, right? It's single threaded on the invocation call and you're waiting for the response to come back. What FastAPI, or rather the movement around modern Python web-based frameworks, what it created was a newer approach to building web applications, and this was called as ASGI, which stands for Asynchronous Server Gateway Interface. So if you've worked with JavaScript and Java-based languages in the past, you would remember that there is actually a very useful library called Ajax, which is asynchronous JavaScript execution, and that was made popular by Google, specifically its Maps interface, because a lot of the rendering of maps is things that can be broken down into modular pieces which can run asynchronously. It doesn't need to wait for user input, and therefore the user does not need to wait for those portions of the map to get rendered. A similar approach came to Python as well, but much later through the ASGI protocol or interface. And FastAPI is actually one such implementation. Specifically, we would use an invocation of FastAPI modules using a tool called as UVCon, and that's using the ASGI interface. Okay, the instance is up and running. Let's go through how you would set up the code. The instance is active, I'm going to click on View in Compute Engine. And we saw a bit of this in last week's lectures as well. And we noticed that there's a primary interface, there's this external ephemeral IP address, which is also there. So I'm going to go ahead and just copy paste it here so that I have access to it at a later point. But for now, I'm just going to SSH into it. Yep. So I'm going to SSH, and when I do that, I'm getting asked to authorize. Since I've already signed in to my account, the authorization happens successfully, hopefully, and then we get access to the the workbench instance itself. So there are artifacts given to you as part of this week's contents, and the artifacts include the FastAPI implementation for the iris classifier. So take a look at that. There are 2 files, and I'll tell you what the reasons for those files are. There's an authentication failure. Let's try again. Okay, there we go. So I'm going to open the FastAPI folder. There are 2 files, like I said. The third file is model.joblib. I've just downloaded this file from the GCS bucket that I've created it in the week 1 assignment. So okay, let's take a look at the V2. The V2 file shows how the FastAPI implementation can be done. First up, you create an application declaration, which has a title. In this case, I'm just calling it Iris Classifier API with some Unicode syntax to denote the iris flower itself. Then I load the model. The model gets loaded from the local file, local directory, I should say, model.joblib. Expecting the input schema to look in a certain way, which matches with the schema that we use for training the iris classifier, sepal length, sepal width, petal length, petal width. Not sure I'm pronouncing sepal correctly, but nevertheless, you get the point. And then since we're building a web service, we need to be able to handle the default HTTP request as well as the specific request that we want to use for providing predictions. So the default HTTP request is just the root of the website, which is slash. So reading the root should result in something which is not a failure. So in this case, I'm just making it return welcome to the iris classifier API. And then the predict endpoint is the one that's actually going to give the prediction for the samples. So here I'm going to use hints again for saying what is the endpoint that I'm handling here. So the app.post predict means that the predict endpoint supports post requests. And what do post requests contain? They contain data which is part of the post request, and that data can be handled in a certain way. So what I'm doing here is I'm taking the data in, and the data is going to be comprised of a single sample at a time because I'm doing predictions of one sample. It's an API meant to be used per sample. So the data comprises of one sample's readings for sepal length, sepal width, petal width. So that's effectively a dictionary, think of it that way. And that dictionary gets converted into a pandas data frame. Now, if you don't do the conversion into a pandas data frame, let's say you treat the dictionary directly as a NumPy array, which is what the first version of the FastAPI implementation shows. So here you see the salient difference is that, let me visually highlight this. There we go. So this data handling happens like a, for instance, a direct class reference, right? For the iris input class, and then I'm individually identifying or accessing the data members of the class, right? Sepal length, etc. So that will individually get the readings, and then I'm constructing a NumPy array, and the NumPy array is then fed into the prediction. In prediction, I'm just calling the model.predict function. Because it's a standard scikit-learn model, the predict function should work, and to that I'm passing the NumPy array. The problem with this approach is that if you look at the way the model itself was trained, it was trained using pandas data frames, whereas what's getting passed here is a NumPy array. So that mismatch will become a problem because the input data types do not match with what the model is expecting based on the training. So that's why version 2 shows you how to create a pandas data frame itself using the single sample inputs that I've gotten as the input data for the post to the predict endpoint. So I'm taking that, creating the pandas data frame, passing that as the input for the prediction. The prediction gets returned, and then I'm finally returning that as a predicted class. So it's fairly easy to get this going because the FastAPI framework abstracts away a lot of the gory details that I don't have to worry about. Okay, so with this I've got the API code ready. So now it's time to execute. So the execution command, I've got this copy pasted. So I'm going to just go ahead and paste it here. So UVCon, like I said, is the name of the library that I will use to execute the FastAPI program as an asynchronous web server. So here version 2 corresponds to the file name. So the full file name without the py extension is where the FastAPI application is available, and within that the app is called as app. Reload here refers to the flag which indicates to UVCon that you should reload yourself as a web service which is live as and when the underlying file changes, which means if somebody else modifies the file or the file is modified in another window, the app automatically reloads, which is quite useful for iterative debugging, but not so useful for production, of course. And finally, host with the 0 IP address just says that listen to requests on all the interfaces available on this machine, because we're going to use the external IP address for our testing. Now, let's just ensure that the name of the app is indeed app. You can see that that's exactly what it is, right? App equals FastAPI title. So that app is what's used further for defining the various endpoints that you'll be supporting within the FastAPI, the root, the predict endpoint, etc. So app is the name that's correct. So the name of the file followed by the name of the application. That's the syntax that is followed here. Okay, so reload minus stores 0 0 0 0. There we go. Great. So now if you see, this UVCon has actually spun up the FastAPI service on the 0 IP address on port number 8000, and it's ready. It's looking for requests, HTTP requests to come to it. And also if you see, it's got a reloader process which is always waiting, looking for any changes to the file that is passed to it as the application file, using its own internal mechanisms called watch files. In this case, the application file is iris fastapi v2.py. So as and when that file changes, this will automatically get reloaded. Okay, so we've got the FastAPI running. The API itself is actually running, and it's time to take a look at how do we test it out or how do we use it. Because it's HTTP, it means that it's accessible as though it's a web-based interface from anywhere, which means let's use a browser. We're going to go back to that external IP address that we cut pasted. This is the external IP address that's ephemerally attached to this particular workbench instance, if you remember. So let me go to this instance and do a slash. Oops. Okay, let me make sure I copied it correctly. Okay, there we go. Yeah, okay. So it says it cannot open the page because it doesn't actually have any requests. Okay, good. This is what we're expecting. Yeah. So by default, the web interfaces are, rather the default HTTP request port numbers are 80. Sometimes it's 8080. In this case, we are actually listening on 8000. So let's go correct that. So let's HTTP :8000 slash. Okay, there we go. So now we're seeing welcome to the Iris classified API, which is there in the root that we actually had. So now let's go to predict. The method is not allowed because it's expecting a post body to be present to it. Post bodies mean it's representing a it wants a post request to be, it's accepting only post requests, not get requests. The default browser request that's sent to a particular website is actually a get request. That's why it says method not allowed. So instead, what we'll have to do is test it out using mechanisms that can issue post requests. So what I've done is to use a tool called as curl. Curl is very good at constructing HTTP requests in all the different types: post, put, get, etc. And you can execute it against an endpoint which is hosted on the network. So I'm going to use curl for my testing. So I want to indicate to it what type of request it is. It's a post request. What is the endpoint that I'm querying? It's going to be this external IP address, port number 8000 and predict. Actually, this is an earlier version of the IP address because the IP address ephemerally changes each time I boot it up. So let me paste the latest IP address. There we go. Predict endpoint is where I'm looking to get the prediction from. And because it's a post request, I'm expecting to give it data. So the data that I want to give it is a JSON type, right? And the data itself is denoted using the -d flag within single quotes. So in this case, the JSON corresponds to the input sample that I want to use for prediction, right? It's got all the 4 variables that are expected in the training. So let's go execute this curl function, curl command. I'm going to go to the terminal, open up a brand new terminal. There we go. And paste this. Okay. So if you see, it says predicted class is Setosa. Okay. Let's go and check what happened to the server when this request was received by it. And if you see, okay, the get ones are basically what we tried from the browser, and it says method not allowed. The post, on the other hand, is handled successfully. So the return code is 200, which means the status is okay, which is great, which is exactly what we expected. Now let's go give it a different. Let me clear the screen. Okay, let's go give it a different petal length, rather variables, just to mix things up and see whether the prediction changes. It should ideally. So I'm going to make it a completely different type of input sample. There we go. Now it's predicting versicolor. Let's go back to the browser. Yep, it's got a post request and it's done okay. So with that, hopefully you've seen what a functioning FastAPI program looks like. It's very simple. Obviously, you can layer additional complexity that you want. And if you want to bring down the web server, all you have to do is just kill the program. The UVCon shuts down and that external IP address no longer exists. Yep, so now it says failed to connect because it couldn't connect to the server. So with that, I think we will we will close this session. Oh, by the way, one thing, you might find that these requests may fail, or the curl request may not execute in time, or it might get timed out. If that happens to you, just go back to the firewall setting of Google Cloud. Okay, so in case you don't remember where that is, so just go to Cloud Console and type firewall, and ensure that the rule that you set up for allowing ML flow also allows this particular port number that we want to run for. So 8000 for me is already set up, so that's why these external requests went through. The instance is the same actually, like in this entire project there's just one instance, and that instance is the one that's being used for the FastAPI setup as well. Okay, so with that we'll close this video. Thanks.